All right, hello everybody. I hope you're having a good night or a good day, whatever time it may be. Um, I am actually recording this video for the third time now because what happened was I had downloaded a recording software, OBS, and it didn't want to work. It was just like, well, the OBS was working, but every time I tried to draw something on Paint, it would just be like really, really laggy. So I'm actually just gonna check right now at the beginning of this video just to see if I can uh, if I can actually write. Let me just try to find my mouse and then zoom in a bit. I forgot to do that. Okay, let me see if I can write something right now. Let's see. Uh, okay, yeah, that's writing actually really nice. Um, yeah, just my computer was really really slow every time it was recording. It was almost impossible to write anything. Um, but anyway, to start off the video, I did want to say one thing that I said in the last two tries that I attempted. I was talking to my friend, and he was asking me just about HKN and what it is. And I was just talking to him about tutoring, how we offer tutoring to students, and you don't have to pay for it. And he was just like saying like, "Oh, do you guys accept donations or something like that?" And I was like, "Oh no, no, we don't require people to pay for tutoring or anything like that." And he was like, "Oh, okay," but like he was talking about just donations and not even just what is it, just payment for tutoring. And I was just like, oh, that's pretty interesting. I actually never thought of that we can still accept donations as long as it's not required. Um, so I do want to start up something new where you can donate either to HKN or you can donate to me for tutoring. Once again, you're not required to do it, but if you would like to donate to HKN, you can probably just come to school and just send some money over to me, probably through cash because we don't have an account set up for HKN. Um, and if you want to send money to me, you can probably send it through Cashapp or PayPal. I'll just leave it in the description. Um, but enough of that self promoting. Let's get on to control systems design. So we are going to do problem one of control systems design. Let me just copy the question over and also just make sure that I am recording as well and everything is visible. I don't want to have to redo the video. So copy that over. Okay, that's good. And let me go to Meet. Okay, I think everything is recording. My voice is being shown on Google Meet, so I think you guys can hear me. So let's continue with problem number one. So for problem number one, actually, let me just connect my charger to my laptop so it doesn't die. So for problem number one, for the continuous time systems described by the following transfer functions, determine the number of poles in the right half of the S-plane RHP, left half of the S-plane LHP, and on the imaginary axis IA, the stability of each, and B, the stability of each system. All right, so for this type of question, I'm gonna make my own question actually, just so that we can, just practice with it. But before I do that, I want to just preface it with something. So if you're taking a look at question number one, and you see that there are these like two equations over here, right? The numbers and the equation itself is going to be exactly the same no matter what. Um, and so you can just basically just like scratch this and just focus on this one. Either way, whichever one you focus on, they're going to be exactly the same, but just as an FYI. Okay. And oh right, I can't do Control Z if I'm charging my laptop because I have to have the other USB-C connected, which connects my keyboard to my laptop. Okay. Anyway, we're gonna do basically like question 0 because this is gonna be my own question. So let's say you get this equation. And there's a reason why I'm going to make my own, and I will show you. You're going to have an equation of, okay, let's say you're going to have S. S is equal, sorry, not equal. S plus 1. S minus 2. What else are you going to have? You're going to have, it's going to be a very long equation. Okay, so you're going to have S squared, and it's going to be minus 9. Yeah, we'll go with 9. And we're going to have also S squared plus 16. And we're going to have, what else? We're going to have S squared, no, not S squared. We're actually going to have S plus 3 squared. We're going to have, and finally we're going to have S squared plus 25 squared. And you guys don't have to write this down. I actually want you guys to just pay attention here. Don't write any of this down. Just watch how I solve this problem. And the reason why I picked this problem, the reason why I just made it up right now, is because it actually should encompass every single equation that you might see, and I'm going to show you how to solve them out. And basically, it'll just be rinse and repeat. So for this first part, for all parts, actually, you're going to be setting the equation equal to 0. So for this first part of S, choose a different color, S, you're going to do S is equal to 0. And that one's very easy because that just tells you S is equal to 0. So you know that this first part is S is equal to 0. The next part is going to be S plus 1. So S plus 1. If you have S plus 1 is equal to 0, then that just means S is equal to -1, right? These are very simple. This one is also going to be pretty simple, S minus 2. You can probably tell S minus 2 is equal to 0. This is going to be S is equal to 2. Okay. Let's try this one. This one should also be pretty simple to do. You have S squared minus 9. S squared minus 9 is equal to 0. If you add the 9, then it becomes S squared is equal to 9. And if you take the square root on both sides, square root of 9 is 3. And just remember that anytime you take the square root, you have to have plus or minus the number. So the square root of the number, which is 3. All right. We have the next one, which is, actually, maybe choose a different color. S squared plus 16. Now this one's a little bit different. If you have S squared plus 16 is equal to 0. If you subtract 16 over, S squared is equal to -16, and then you're taking the square root. Now, what happens if you take the square root of a negative number? You're actually taking the square root of two different numbers. So let's write this. The square root of S squared is obviously S. Well, let's split this up. So what you're going to be doing is you're going to be taking the square root of -1 and the square root of 16. The square root of -1 is what's known as an imaginary number. So this is an imaginary. Imaginary number. So you can't take the square root of -1. It's just impossible. So we just label that as I. Okay. And for 16, this just follows the same the same rules that we were doing before. It would be I4, and this is all plus minus, right? So basically, it's just 4 times I. You can't do anything with it. Another way you could write it is technically plus minus 4 square root of -1, but we do have a word and an explanation for this, so we're just going to be using I from now on for this process out. But that's just a little bit of an explanation of how I got I. This next one. Okay, so this next one is actually pretty interesting because it might not be too obvious to everybody on how to do this. So we're going to be doing s plus 3 squared. S plus 3 squared. All right. So you might be thinking, okay, well, I could just set this equal to 0, and if I take the square root on both sides, then this is just simply s plus 3 is equal to 0, because the square root of 0 is 0. That is exactly what you don't want to do, because if I were to rewrite this equation, this is actually, because it's squared, it's just s plus 3 times itself, right? So this is technically s plus 3 times s plus 3. And both are equal to 0, right? So technically, we could also write it like this: s plus 3 is equal to 0, s plus 3 is equal to 0. And if we solve out for this one, then we're going to get this one. So just solve out for one of them. If I do this, s is equal to -3, then we find out both of the roots. S is equal to -3, right? Now, the thing about this is if the square root is on the outside, like I just showed you, right over, where is my mouse? Right over here. If the square is on the outside and not like over here, then you know that this is going to show up twice. And I'll show you how to graph this in a little bit. But we'll be moving on from that just to do the last one. So with the last one, let me get the last color. Let's go with brown. That'll show up. S squared plus 25 equals to 0 squared. For this equation, as I said before, if you have a squared, you could just split it up, right, into something like this: plus 25 equal to 0. Right, so you have something like that, and as I said, you only have to solve out for one of them, and then you'll know the other one. So if I were to solve this out, this would be s squared is equal to -25. And if you take the square root on both sides, here's the -1 times 25. So you'll get s is equal to plus or minus I. Also, I forgot one other thing. In mathematics, we use I, and in what is it? In electrical engineering, we use J, and these are both interchangeably. So if I write I or if I write J, you can they're just interchangeable. The proper way to write this is actually to write it as J, because we are electrical engineers. So let's continue that trend. This is J, and this is 5, right? So you have plus and minus J5, but you also have another plus and minus J5 over here. Remember this one? So this is 4 roots. This is basically plus and minus J5, and it's going to show up twice for the positive J5 and twice for the negative J5. And this is kind of like the biggest one that you're going to see. I also forgot to box this one in to show that we're doing it. But yeah, so we have all these roots, but we also need to know how to graph it. So let's do that. To graph it, so our first one is s is equal to 0, and we did that in purple, or like really, really dark blue. So s is equal to 0, that's obviously going to be over here. We also have s is equal to -1, that one will be over here. If it doesn't have a j or an I, whatever you want to say, it's going to be on the x-axis. So this is -1. Okay. We have s is equal to 2, and that's in burgundy. So this is s is equal to 2, right? And I'm not gonna, I'm not gonna be doing like these points, right, to say 1, 2, 3. I'm just gonna put the number above it. It might not look as a graph should be, but it's whatever. Anyway, so we have s is equal to plus and minus 3. So if we have plus and minus 3, then that means it is going to show up on positive 3, and it's going to show up on -3. We have those two. S squared plus 16. Sorry, s squared plus 16. This is s is equal to plus or minus j4. So we have plus and minus j4. What we do here is on the y-axis, you do positive j4, and over here you do negative j4. All right, so if you have a j or an I, whatever you want to say, it's going to be on the y-axis for sure. The next one is s is equal to -3, but it shows up twice. So what should we do in that situation? Actually, I just noticed that we have a -3 already, but that's fine. It can show up 3 times in one spot. That's completely fine. So it would be like this, and then there would be another one. So there's actually three x's on -3. Okay. What you can do also, if you just want to like make it a little bit more clear, instead of doing like a double x on the same point, right? What you can do is you could actually make it into a star. There we go. So now it looks a little bit more clear that there's 2 points because it's a star and not a cross. Okay, so we have that. The last one is going to be in brown. And it's going to be s is equal to plus or minus j5, but it's going to show up twice. So what does that mean? It's going to show up twice at positive j5. So there should be 2 x's or a star. And it's going to show up twice over here at negative j5. All right, and now we've just plotted this whole graph. We know how to plot the graph, and we know how to do the equations. But we don't know necessarily how to do this RHP, LHP, IA, how to label them, right? And we're gonna move on to that right now. So let's go over here. So this graph was very nicely drawn by Professor Ozturk. And I'm just going to copy it from him. So this y-axis over here is the imaginary axis. That's what we call IA, imaginary axis. Over here, everything on the left side of the imaginary axis is the left-hand pole, LHP. Lastly, everything over here is known as the right-hand pole, or RHP. So in the first question, or in the first part of the question, when it says number of RHP, number of LHP, and number of IA, we know how to do this. So there's 2 in the RHP. There's going to be, this is a lot, going to be 1, 2, 3, 4, 5, 6, 7, right? Because there's double points on both of these. There's double points over here and over here. So it's going to be, what did I say it was? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 7. 7 on the IA, and then over here we have 1, and then we have 3 over here. So this is going to be 4 on the left-hand pole. So over here it'd be 2. This will be 2, 7, and 4. But I don't have to write it there because this is for question number 1. We're just doing question 0. And okay, so we have that. We're going to talk about asymptotic stability and BIBO stability now. So for asymptotic stability, we have 3 cases. We have stable, marginally stable, and unstable. Okay, so when it's stable is very easy. That means every single point is on the left-hand side, no matter where it is. It's on the left-hand side. Nothing is on the imaginary axis. Nothing is on the right-hand side. And lastly, there are no repeating points. So if it's stable, it's a very easy problem. That means everything was on the left side, and there's no repeating points. It's not on the imaginary axis, and it's not on the right-hand side, okay, or right-hand pole. If it's marginally stable, then that means there are points on the imaginary axis, regardless if there are points over here, right? It doesn't matter anywhere. There are points on the imaginary axis, but they don't repeat. So if there is a repeating point, or maybe I should do like this. There's a repeating point anywhere that's not marginally stable. It has to be on the imaginary axis. It can't be anywhere on the right-hand side. And there's no repeating points. That is marginally stable. For unstable, if there is any point on the right-hand side, or if there are repeating points anywhere, this is an unstable system. All right, so those are the 3 different cases. This is for asymptotic stability. This is for asymptotic stability. For the next one, it is BIBO stability. BIBO stability almost follows the same format. It has stable and has unstable, but it doesn't have marginally stable. So basically what that means is, remember marginally stable, that if there's anything on the imaginary axis or anything over here, right, this is going to be marginally stable. In this case, if there's any one point on the imaginary axis, we just treat it as unstable. So it's basically everything from unstable applies here, and everything from marginally stable also applies here. All right, so now we know how to do these types of problems, and now we can actually do these problems. The only thing I didn't go over was the reason, but I'll show you how to do the reason in a little bit. Okay, let me also get my sheet. Okay, so we have this. Okay, so let's just start doing this problem. I do also want to say one other thing. This is the easiest problem that you will ever have in this entire class. I want everybody to get a 10 out of 10 on this problem. Do not make any mistakes, or I will be very, very sad, because this is the easiest problem that you can ever have. It's like very, very simple math, and there should be no mistakes. Take huge priority on this. Don't take too long with this problem, but also don't rush it. Just take your time with this problem and recheck it, because if you don't get a 10 out of 10, then that's like a lot of your points, because the next problem is actually a little bit harder. So just make sure you know this through and through, just like you know this like the back of your hand. But anyway, let's go to problem number 1. So for problem number 1, we have s squared minus 64 squared. So we have s squared minus 64 squared. Now, you can do so. You can just like look over here, and you can be like, oh, okay, so this is basically the same rule, right? Because you have an s squared and you have a square on the outside. So let me just do all this math. You don't have to do the math, because all you have to know is that okay, so one thing is that this is a negative. So there's not going to be a j over here, right? If it's negative, if it shows a negative, then it's going to become a positive. And but there still will be 4 values in the end. So you can just skip all the math, and you can say, okay, so if there's not going to be a j, then it's going to be s. And what you can do, just to keep track of everything, you can say s1, 2, 3, 4 is equal to plus and minus 8, right? So 2 on positive 8 and 2 on negative 8. And you can just do this just because you can just memorize the rules. If you're better at memorizing stuff, then you could just memorize the stuff. If you're better at solving it out, you'll always have solving it out in your back pocket. But this is just like, you can just kind of like look at the equation and then just know the answer. Well, just as long as you don't make any mistakes over here. If you have to do the equation, then do the equation. All right, we have s plus 5. That one's easy. S5 is equal to negative 5, right? So the fifth s is equal to negative 5. S6 is equal to negative 4. Just to remind you guys, this S6 is just keeping track of how many s's there are. So over here, there's 4 s's. Here's another one, and here's another one. Okay. And then s squared plus 16. S squared plus 16. S squared plus 16. Okay. I just wrote the equation. S squared plus 16. That's going to be plus or minus J4, right? Plus or minus J4. Okay. Yep. And how would you draw this graph? So let's draw this graph out. J4, negative J4. Okay. Okay, so you have that, which is 8. And it shows up twice here. That's why I drew a star. You have negative 4. You have negative 5. And you finally have 2 on negative 8. All right, so that's how the graph looks. Now that you have the graph, you can fill out part 1. So how many are on the right-hand side? Well, obviously there's just 1. So, oh, sorry, this is 2. Even when I draw the star, I forget that there's 2 over here. So just don't make that mistake on the quiz. So there's 2 over here. There is 4 on the left-hand side, 2 that shows up on -8, and 2 that shows up, one that shows up on -5, and another one that shows up on -4. So that's 4 on the left-hand pole. And on the imaginary axis, there's 2. All right. Okay. Also, if you have s is equal to 0, that is on the imaginary axis. Just letting you guys know. Sorry, wait, did I write? I wrote 4. This is supposed to be 2. Anyway, so asymptotic stability. So let's take a look at this. Okay, well, you have some on the imaginary axis, and that could be marginally unstable, but there is some stuff on the right-hand pole, and there's also what is it? There's also points that show up twice in one spot. So we have 2 reasons I have to show why this is unstable. So this is going to be unstable. So the reason is, well, of course, plus and minus 8, because -8 has 2 poles. Sorry, -8 has 2 points that show up in the same spot, and +8 also has 2 points that show up on the same spot, and it's on the right-hand side. So there's that. And of course, this is going to be unstable for the same reason of plus and minus 8, but also for the reason of positive J4 and negative J4. Because remember, there is no marginally stable in this problem, in the Bibo stability. So this is also another reason as to why. I don't know if he'll take off points if you just exclude that reason, because technically if you put plus or minus 8, that still is a reason, but I can see why he would take off points if you forgot plus and minus J4, because that is another reason as to why it is unstable. All right, 2 and 3 are basically the exact same problem as 1. So I'm just not going to do that. I'm going to do IV, which is a little bit not special, but it's just different. So first one we have, I could do this in red. We have s is equal to 0. That one's very easy. S squared plus 16. All right, with s squared plus 16, you have s is equal to, oh, sorry, this is s1, this is s2, 3. S squared plus 16, you have negative 16, so this is going to be plus and minus J4, right? Yep, plus and minus J4. The next one you have s plus 1. All right, so we have s is equal to -1. That one's very easy. S4 is equal to -1. Last one, s plus 7. S plus 7, that's equal to s is equal to -7. That's the 5th one. Okay. And if we were to draw the graph, it would look something like this. We have -7, -1, and there's going to be 1 at 0. There's going to be plus and minus, plus J4, minus J4. Okay. So, number of RHP poles. RHP poles. I thought RHP stand for right-hand pole. So right-hand pole poles. I don't know. That's I might be calling it wrong, but it doesn't matter. Whatever you call it, it's just a word. So number of RHP poles. There's nothing on the right side of the graph. Right? There's nothing over here. So this is 0. Very easy. Number of LHP poles. This is 2. -7 and -1. 2. And number of IA poles. Well, there's 3 plus J4 minus J4 and also 0. I forgot to write 0. So there's 3 of these. Now, okay, so the asymptotic stability. That does not look like a good 3. The asymptotic stability. What is the asymptotic stability here? Well, is there anything on the right-hand side? No, there's nothing on the right-hand side. Are there any points where there's two of them in one place? Something like this? No, there's not. Everyone shows up. Every number shows up at a single point. So it's definitely not unstable. But are there points on the imaginary axis? Yes. So it's not stable either. So this has to be marginally stable. There's 3 points on the imaginary axis, and that is the exact same reason, right? So plus and minus J4, and this is also 0. All right, so all of these points make it marginally stable. For BIBO stability, well, there's either stable or unstable, and we know that if something is marginally stable for asymptotic stability, then it has to be unstable for BIBO stability. So this is going to be unstable. And it's for the same reason, plus minus J4 and 0. The only time it'll be stable is if there's numbers only on the left side, and there's no repeating points. And if it's stable for asymptotic stability, then it's also stable for BIBO stability. Is that going to happen on the quiz? Most likely not, because that's a very easy problem. But don't count it out. The problem will most likely be marginally stable or unstable. Or if there's like 2 problems. There's definitely going to be multiple problems. Okay, so then there might be, multiple parts, right? Because there's 4 over here. So yeah, stable might show up on the quiz. Probably all of them will show up on the quiz. Stable, unstable, marginally stable. But yeah, as I said, this is a very easy problem. You can either just memorize all of this stuff, or you can just know how to do it. Just know how to do the equation. You should do both, right? Because you should know how to do the equation. If you forget, if you like memorize it and you forget, and you should be able to also memorize it, because you don't want to do these equations every single time you have to do one of these. This is 4 parts, right? This is a 4-part problem, so it would take a really, really long time if you have to do these equations out every single time. Anyway, that is question number 1. And now we are going to move on to question number 2. Okay, question number 2. Let's see. I have to go back to the document. How long have you been recording? Probably for a really long time. I talk a lot. A large antenna as shown below. Okay. So this is... Okay, so we have that. And we also have... Okay, I have to copy... Let's see. There we go. That looks good. Sneak that in. Okay. So this is problem number 2. A large antenna, as shown below, is used to receive satellite signals and most accurately track the satellite as it moves across sky. Okay. A very simplified model of the system is depicted in Figure 1b. Okay. Find the closed loop transfer. Okay, so for part A, find the closed loop transfer function. GCS of S is equal to CS over RS. When ds is equal to 0, when ds is equal to 0, then determine the parameters Ka, Km in terms of zeta and omega n. Okay, whatever. How do you do this type of problem? So, first of all, you guys might have noticed. Whoops! Why is this? I can't access my painting tools anymore. Why? Oh, I gotta go to home. View. Okay, there we go. So the first thing to notice about this problem is that there is an amplifier over here, and you might be thinking, "What the hell is an amplifier? How do you do that?" You can just treat an amplifier. Whoops. You can just treat an amplifier as a block. Right? You're just going to multiply it. Right. So if I were to draw it like this, same exact thing, right? Same exact thing as this over here. But I'm gonna continue to draw it as an amplifier just because he has it as an amplifier. So okay. So to start this problem, this is a very big problem too. Okay. Okay. So to start this problem, the most important thing is to read the question. You always want to read the question, even for this one too. You always want to read the question in case he catches you off guard and surprises you with something. Or if there's something that you forgot and the question just tells it to you. Find the closed loop transfer function, blah, 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 when ds is equal to 0. Okay, so we're finding the closed loop transfer function when ds is equal to 0. What does that mean? When ds is equal to 0, let's take a look at this graph. We're going to zoom in a little bit. When ds is equal to 0, that basically means that this line just goes away. Now, this line is going into a summing point, so this was supposed to be positive, but that is gone now, and this is supposed to be positive, right? So basically what happens is that summing point just goes away because this value is still going to be positive no matter what, if it was going in positive now or when if it was going in positive before, or after you made ds is equal to 0, it'd still be positive. So we're going to redraw this to make it look like this. So rs stays the same. Rs. There's a summing point here, and I like to draw it like this because this is how we learned it. There's going to be a Ka. The summing point goes away, and it just goes into this box. This value still stays negative, so 25 s plus km. 1 over s. This is very simple to redraw. Not much went down over here. Okay, so this is our block diagram, or sorry, this is our new transfer function. And we are trying to find CS of RS, right? And we have to combine all of this into a single block, as we did on the last quiz. Oops. Combine all of this into a single block. So if you remember the equation from the last quiz, CS over RS, this becomes, so all of these terms are being multiplied together because they're just on the same line and there's no like summing point in between them or anything like that. So I'm just going to rewrite it as 25 Ka over S times S plus Km. Okay. And after that, we have, since this is negative, we do 1 plus, not 1 minus. So 1 plus, and then it's just the same equation because there's nothing on the secondary line over here. All right. So 25 Ka divided by S times S plus Km. All right, so we have this equation. You might be thinking, okay, well, this is like really big. way too big to like solve anything out for, so we gotta simplify this. How do you simplify this? Okay, so I'm going to show you how it is simplified, and then I'm going to show you the easier way to simplify it, because I just before I had figured out a way. Oh, okay, this is the easier way to simplify it. Okay, so we have this. So 25k s plus km. So what we do is, how about we write it as an easier division sign? Okay, this is going to be the long way. So s plus km, and it's going to be divided by this equation, 1 plus 25ka over s times s plus km, right? Okay, so we have this. Now, we see that there's a lot of stuff going on over here, because what we want to do. Hold on, let me just get it. No, that's parentheses doesn't look that good. That parentheses doesn't look that good. There we go. So there's a lot of stuff going on with this part of the equation. What we want to do is we want to combine this into a single term. Just a numerator and a denominator. How do we do that? Okay. So we have this, 1 plus 25ka divided by s times s plus km, right? How are we going to combine 1 with 25ka over this? I just don't want to say it again. How are we going to combine these two? Well, if you want to combine them, they have to have the same denominator, right? So to get the same denominator, we are going to multiply 1 by s times s plus km stupid. Okay, s plus km over s times s plus km. Why are we doing that? Well, what is this? S times s plus km over s times s plus km is equal to 1. So you're basically multiplying 1 by 1, but in a very complicated way. If we do that, we would now have... Oh, okay, I got to the end of the page. I thought it froze for a second. So let's just copy this over. Okay, so we have this. And you're supposed to multiply it by 1, right? You're multiplying 1 by 1, but it's just a very complicated way of writing 1. And what does that get you afterwards? What it gets you is s times s plus km divided by s times s plus km plus 25ka divided by s times s plus km, right? And you look at this and you're like, oh, okay, so this has the same denominator over here, right? So I could just write that as one equation. If I just add these two terms, the denominator, if you're adding fractions with the same denominator, the denominator stays the same, and the numerator just gets added to each other. So this now becomes s times s plus km plus 25ka over s times s plus km, right? And then we still have this part, 25ka over, oh, I forgot to write this, s times s plus km, right? Okay, so we have now a fraction divided by a fraction. Now, we don't like dealing with that kind of stuff. I always keep forgetting to do this end parenthesis. I don't know why. We don't like dealing with that kind of stuff. So we're actually going to deal with multiplication. How do we get it to multiplication? Keep, change, flip. Just remember that. So you keep the first term. This is the first term. Keep this. You multiply this, you change this, division to multiplication, keep, change, and the last one is flip. So we're going to put the denominator in the numerator and the numerator in the denominator. So we have s times s plus km divided by s times s plus km, plus 25 ka, right? Okay, I think I wrote that right. Yep. And okay, so we have this equation, and now this is very simple. What do we have here? Well, we have something in the numerator over here, and something in the denominator over here that can be canceled out. So this cancels out to 1, and this cancels out to 1. So now we just have 25 Ka divided by S times S plus Km plus 25 Ka. Ta-da! All right, so let me show you how to do this in a very simple way. So we're gonna start from the beginning over here. So you have, so let's say we have a value. We have a value like this. You have A. I'm going to even color code this just so that it's very, very simple to see. A over B divided by 1 plus A, oops, A over B. Oops, I photoed that one. B. All right, so we have this equation right here. What is this equal to? Well, we can just look at the answer and find out what it looks like. The answer is 25 Ka over S times S plus Km plus 25 Ka. Okay, so let's just rewrite that. So basically, this becomes A over, I already forgot. What was I doing? I have the answer here. Oh, okay. A over B plus A, right? These look exactly the same. So we have, this is our A, this is our A, this is the 1 plus, and this is our B, right? And if I were to bring the answer down to over here, if I were to just copy and paste the answer so I could compare. Okay. Select, Control C. Okay, so over here. Look at that. This is our A, and over here is our A2, and over here is our B. But it has to be in this form, right? If there's even one value over here that is different, this will not work. So let's say if I multiplied, let's say this was multiplied by, I don't know, a value of B, right, over here, then it just won't work. this equation just does not work the same way, or if there's a value of b over here, it does not work. Okay, so just keep that in mind, that it has to be in this form. But if you do get the same value, where I show you over here, over here, and the same values over here and over here, and you have the 1 plus, then you can do this. I think if it's 1 minus, then the only thing that changes is this positive becomes a negative, but I'm not going to do that out. It's probably going to be exactly like this anyway. I think that's the only thing that changes. That'll actually be a task for you guys to figure that out if that's the only thing that changes, because you guys should be able to do these types of problems now. So there you go. This is a very, very simple equation that you can just memorize off the top of your head, and it'll take you like literally 10 seconds to write this out on the quiz, right? So at the beginning of the quiz, you could just write this equation out, and you can just take 10 seconds to do this problem and probably finish it faster than me, because I will just do it the long way anyway. I'll probably forget my own equation. Anyway, so we got up to this point. So this is our answer. The only thing, actually, I'll explain it afterwards. So the next part is we have to find Ka and Km. Now this is where we use that equation that Professor Osterk showed us before. He actually showed it to us quite a few times. GS is equal to omega n squared over s squared plus 2 zeta omega n s plus omega n squared. Right? So we use this equation, and we're going to compare this one with this one. We're actually not comparing it. We're actually going to be setting things equal to one another. So the most important thing that we have to look at is actually, well, let's start with this value over here, right? These two values, these two are equal. These two are always equal to one another. And that's the same thing over here as well. These two are equal to one another. And if you're doing this problem, and if you get like two different answers, right, or sorry, two different values for these parts, you might be doing the question wrong. Now, one thing is that it is a little bit different. I found out for part C. But if you look at the practice quiz, after you do part C, you're supposed to do the rest in MATLAB. So I still think that even if you want to do this type of problem, these two values should always be equal to one another, because if not, well, then obviously you have to use MATLAB, and he can't put that on the quiz. So that's one way to check and see if you got the right answer. Anyway, moving on. So for this part, what we're going to do is we're going to do 25 Ka is equal to omega n squared, right? So we're just setting this value. Oops. We're just going to set this value equal to this value. Simple. And we said in the question, we have to solve out for Ka. So the only other thing we can do is do Ka is equal to omega n squared divided by 25. Right, and there is no zeta here. It says in the problem, determine the parameters Ka and Km in terms of zeta and omega n. Well, there's no zeta here, so that's fine. If there is no zeta there, then it's completely fine. The only problem would be if there was no omega n, right? Now for the next part. So you might see over here that these two are a little bit different, right? That's not too much of a problem, because we just have to simplify it, and it'll look exactly the same. So right here, we're just going to do an extra step. So we're going to rewrite this equation to be 25 Ka divided by, we're going to just distribute this value. So it's going to be S squared plus SKM plus 25 KA. All right. We now have this. My computer is dying, but I should have enough battery to finish this off. 25K, S squared, S plus SKM plus 25K. Okay, now it kind of looks a little bit more like the other one, where we have this S squared, right? Luckily, we don't even have to worry about this S squared. That's not what we're solving out for. You just don't focus on that. What we do focus on is this part over here. SKM is equal to 2 zeta omega n s. SKM is equal to 2 zeta omega n s. And the one thing you can do is you can cancel out these s's. These s's should always cancel out. So you're left with this 2 zeta omega n. Km is equal to 2 zeta omega n. And you're done with part A, because you found Ka and you found Km, and it's all in terms of omega n and zeta. Now, we're going to move on to part B. Choose, whoops, I could actually just go to the problem. Part B, choose the parameters Ka and Km such that the percent overshoot, the percent overshoot, and then he shows 10% is less than the percent overshoot, which is less than or equal to 30. And also that the settling time, Ts, is less than or equal to 0.8. Okay, so what do we do here? So first, you have to take a look at the graph. We do use the graph in this problem, which is good. This graph is nice and easy to look at. Let me just copy the graph. Remember to take your graph to the quiz, because I don't know if he'll give extras. Just come prepared. Okay. So he says he wants the percent overshoot to be greater than 10%. What is it? Percent overshoot. And less than or equal to 30%. Right? That's what he wants the percent overshoot to be. So you can literally pick any value that is greater than 10% or is less than or equal to 30. Luckily, I picked a value that gives us nice numbers. You could use whatever number you want to, but like you might get not as nice numbers on the quiz. That's fine. You're still doing the problem right, but I just choose this number 15. So we're going to do 15. Right, we're going to do percent overshoot is 15, and we're going to draw our line all the way over here. And that is, oops, one. Let me just draw this. Okay. That is 0.5. We're going to say that that's 0.5 because it looks like 0.5. It might be a little bit above, it might be a little bit above 0.5, but we're going to say that that's 0.5. So this is our zeta value, by the way. So we're going to say zeta is equal to 0.5. Now, for the settling time, he also says Ts is equal to, is less than or equal to 0.8 seconds. All right. If it's less than or equal to 0.8, well, I'm just going to make it Ts is equal to 0.8. Because it could be less than or equal to 0.8, so I'm just going to make it 0.8. All right, so we have these two numbers. These are our two numbers that we are selecting, as he puts it. This one and this one. Okay. These two numbers. All right. Okay, so now we have to use the equation. You're going to have to memorize this equation for the test. TS is equal to 4 over zeta omega n, which is less than or equal to did I do this wrong? TS. Oh yeah, that's wrong. Okay, is less than or equal to TS. Okay, so that's the equation that you have to know for the test. Okay, so since we already selected TS and zeta, we can get rid of this greater than less than sign, right? And our equation is going to be 4 over zeta is going to be 0.5 omega n, not m, n, is equal to 0.8 because we selected 0.8, so we know that it has to be exactly equal to. It's not going to be less than or equal to, right? 0.8. So we're solving out for omega n if it's in the denominator over here, and you're trying to like switch it out with this. You can divide and multiply and do stuff like that, but it's going to be. This is going to turn into, you can just switch the places of the numbers. So 0.5 times 0.8, 0.8 is equal to omega n. See, I just switched omega n and 0.8. There we go. All right, so we will now find out that omega n is equal to 4 divided by 0.5 times 0.8. That is going to come out to be 10. Omega n is equal to 10. So we're selecting omega n is equal to 10. So now that we have omega n is equal to 10, we can find Ka because this only has omega n in it. Actually, we could find both of them because we know zeta as well. But we're going to start with Ka. So Ka is equal to 10 squared divided by, what is this? 25, right? So this is equal to 4. Simple. Ka is equal to 4. Km is equal to, what was it? 2 zeta omega m. So it's going to be 2 times 0.5 times omega n. Omega n is 10. All right, 2 and 0.5 cancel out, so Km is equal to 10. Very, very nice numbers. You could get like fractions. You could get like really big decimals on the test. I just got lucky. Honestly, it wasn't even about I knew which numbers to pick. I just got lucky. So we have Ka and we have Km, and these are the answers to problem number 1. Or sorry, problem number 2, part B. Ka is equal to 4. Km is equal to 10. Just remember that if you wanted to select any other number, you can. You don't necessarily have to get this answer as the correct answer. You could have many, many answers, very different from mine, but that are still correct. Okay, and we've come to the final part, which is part C. Find the closed loop. Sorry, my voice is going. Find the closed loop transfer function GDS of S is equal to CS over DS. RS is equal to 0. in terms of Ka and Km when Rs is equal to 0. What's the most important part here? Rs is equal to 0. Okay, so we're going to shoot. I drew over the graph. Okay, what we're gonna do here? I'm gonna scroll up to the top, and I'm just gonna copy it from the original document. Luckily, I still have it open. Okay, place that over here. So for part C, we're saying that Rs is equal to 0. So all of this gets crossed out, right? This line. Now, what happens here, very interesting, is this line is going into a summing point. But that summing point, so for Rs, it's positive, right? But this one is negative. So let's say we're the value 1, right? And we're coming from this line. Okay, so we're a value of 1. We go into the summing point, it's negative, right? So we're going to say that this is negative 1. And then it goes into this amplifier, so it comes out as negative Ka. And then it goes on its merry way into the summing point over here. Right? So we're going to redraw it that way that negative Ka can show up properly in the graph. So first of all, we're going to draw okay, let's redraw the graph. Just like this graph over here. And then we can like make it look prettier. So I don't like drawing my summing points like this. So I'm going to draw it like this. So there is a ds over here. And this one's positive. Positive ds. This one is a 25 over s plus km. Goes into 1 over s. CS. Okay, and then there's a branching point over here. And that's when things start to mess up. So we have negative 1 and negative Ka. So the negative, okay, here. This is how we do it. The Ka is going to go down here. Okay. The negative 1 is going to be shown over here at this summing point as a negative. And this is how we get this negative Ka. You can do it so that like this is a positive summing point and this is negative Ka, but let's not do it like that. Let's do it as he teached it. So this is negative over here, and we can just redraw it, or we can just redo the steps. Sorry, redo the steps to show that this is correct. If I could find my mouse, I somehow selected the Windows button. Come on, there we go. So we're a value of 1, and it's like, okay, so we're going this way. Oh, we hit a Ka, so now we are 1 times Ka, or Ka. Then we're going over here, and then we're going into this summing point, and we know that our value is going to be negative, so it comes out as negative Ka. That's how you know. It is raining right now. Interesting. But this circuit looks a little bit wonky. So I'm going to redraw it. I won't explain it, but because you guys will be able to see how it should be. So I'm going to redraw it like this. Goes like this. You guys will just be able to like immediately tell, oh, okay, I see. 25 s plus km. 1 over s. CS. Goes like this. This is K. Negative. Does this look a little bit familiar? This looks a lot like the circuits we've been solving for, right? Or you have a main line over here, and this is a secondary line. It doesn't look all weird like this problem, or this this block diagram or transfer function, whatever drawing. It's the same thing though, right? The ds over here, I could probably use color to show. The ds over here is positive, just like this one, and it's going into a summing point, right? Out of that summing point comes this 25 over s plus km times 1 over s. Same thing over here. And then there's a branching point, right over here and over here. And then we have this line. We have this line over here. It goes into the Ka, and it goes into a summing point as a negative value. Right? Same thing over here. We have a branching point. There's a line coming over here. It goes into this Ka, and it goes into the summing point as a negative value. So we have the exact same block diagram, just redrawn in a different way to make it a little bit easier to know what we're doing. And now we have to find Ka. Sorry, we have to find Ka and Km. Wait, find the closed loop. Oh, I'm sorry. We're trying to find the closed loop transfer function. So we have over here. Come on. Cs over ds. So let's just write the equation. So we have 25 over s plus km. This is times s, right? Because these two multiply together. We have Ka. We have 1 plus 25 s times s plus km times Ka. Do you guys see what I see? Well, first of all, this Ka can move to the top over here because it's just being multiplied. So let's just draw that in over here. But this does not look like our equation from before. If you saw, actually, I could just rewrite the equation over here. We have A over B divided by 1 plus A over B, right? This A is completely different from this. So these two are just not A. They're not the same value. So we cannot use this equation. That's why you should know how to do the step-by-step process, because we can't reuse it. So we will actually have to solve this out step by step, but we could do it a little bit faster. So we have this 25. I'm going to skip right to the multiplication part. Plus Kn. All right, so if we combine this, so first of all, there's a multiplication. If we combine this, it goes, this should be S times S plus Km. And on the bottom, there will be an S times S plus Km plus 25K. Right, I did it just very quickly. The S, I flipped the S times S plus Km, right? And then like 25Ka. Sorry. I combined the 1 plus 25Ka divided by S times S plus Km. And I then flipped it. It's just as simple as that, honestly. So after that, we cross these out. And now we're left with the transfer function. So this is CS over ds. Oops. Yes. The transfer function is now 25 over s times s plus km. Do you guys see what I see? I said before, well, first of all, we can just simplify it a little bit more. This, we don't have to, but I'm going to do it. Plus 25k. You can figure out what I'm seeing. So we said before that this should always be equal to this. But these two numbers are different. This is 25 and 25ka, which is completely different. Now, this would be a problem if we weren't already done with the if we weren't already done with the answer. This is the answer, right? Oh, oops. This right here is the answer over here. And if you were to go on to part D, it says with the values of the parameters Ka and Km found in this part A, find the effect of the unit step disturbance on the antenna position with MATLAB. We cannot use MATLAB during the quiz. So, and also for part E as well, verify the part B with MATLAB. So basically, we're done. We literally just can't do any more. So this is the one scenario where these two values are not the same. But since there's no more that we have to do, we don't have to worry about it. If it was different over here, sorry, if the values were, hold on, I can find it. Yep. If the values were different over here, and we still had to do a whole bunch of math to find km and 25ka, I literally just wouldn't know what to tell you because the values are not the same. So what do you set it equal to? Do you do 25ka is equal to omega n squared, or do you do 25? Actually, I could write it over here. Or here. Do you do 25ka is equal to omega n squared? Or do you do 25 is equal to omega n squared? Which one do you do? Or is there its own equation that we don't know in this special case that we have to learn? That's probably it. Either we have to learn a new equation, or we just can't do it, and only MATLAB can do it. Only the computer knows how to do it, which is probably not what's happened. But we don't have to know. We don't have to know the answer for this quiz. So, right over here we have all the answers for the first problem and the second problem. Go back and watch the video again if you need to, or just watch the parts that you weren't sure. If you have any questions, just remember that I have a Google forum right over here. Actually, I would have to share a tab, so let me stop presenting. And let me go to tab. So just remember, if I go to, let me go to the dashboard. So if I go to Control Systems Design, and I go to the top of the page, Charlie's Tutoring Forum, we have the tutoring forum for practice quiz number 2. So if you have any questions, please just send it here. I'll try to respond as fast as I can. But it will be the weekend, so I probably won't check it as much, but I will check it. There's 0 responses so far. If you have any questions, you could do it here. You can also, by the way, if you press reply and you go to advanced, you can upload images. You could upload videos if you really want to, uh, audio recordings. You could upload a whole bunch of stuff. You don't just have to upload a question, just a text question, right? Oh, there we go. My battery's running low. So you don't just have to upload a text question. You can upload the material that you're confused on, and I can literally just respond, make some notes on the image that you send, and just like send it back to you guys. So if you have any questions, please just ask it there. And yeah, that's pretty much it. I hope you guys do well on this quiz. Remember that the first part is much harder. Sorry, the first question is easier than the second one, and I don't want anybody to to get the first question wrong, because it is very easy. Even if I get it wrong, I would be very, very disappointed in myself, because I would have known that I was just like rushing through it. But this isn't the hardest quiz. As long as you know the math, then you'll be fine. And yeah, that's pretty much it. So thank you guys for watching. I hope you do well on the quiz, and I will see you guys later. Have a good one. Bye bye.